In this video, you are going to learn how to solve a system of equations using what's called substitution. So here's the question. Is there a way to find a solution to a system of equations like that? Like this? Yeah? Without graphing the equations? Like, what if I don't always want to graph them? Is there a way to find out where they cross so I don't have to graph them? And the answer is yeah. It's called substitution. If you think about what substitute means, it means like to take out something and put something else in, or to replace. And that is because that's what we're going to do in this process. So when would we use substitution? We use substitution when at least one equation has an x or y already isolated. What does that word mean, isolated? It means by itself. So when you have a system, one of the equations needs to have an x or y by itself. Take a look at the first system that I've placed over here on the left-hand side, okay? In that system, does at least one equation have an x or a y by itself, isolated? The answer is yeah. This one right here. You see that, how that y is all by itself on that side? So this would be a good one for substitution. Go ahead and circle it. Take a look at the second system. Do I have an x or y that's completely by itself? I don't. Even though I have this y, it's on the same side as the 4x, so it's not isolated. This would not be a good one for substitution. Take a look at the third system. Do I have an x or y that's isolated in this system? The answer is yeah, right here I have an x by itself. And take a look at the last one. Do I have at least one equation with x or y by itself? Yeah, actually I have two. I have two equations with y by itself. So all I need is at least one. This would be a great one for substitution. Let's go ahead and see what substitution is all about. In example number 1, I have two equations, y equals 6x and y equals x plus 15. I want to find out where these lines cross. All right, cool. My first equation tells me, now this is going to be kind of hard to teach by video, so let's see how we do. Y is equal to 6x. Those things are actually the same. Y is equal to 6x. That means that the y, in other words, is 6x. They are actually equal to each other. So what does that mean? If they're equal to each other, imagine you have a $10 bill and you have two 5s. Those two things are equal, right? So whatever store you need a $10 bill for, you could also use two 5s, right? Because they are equal. What does it mean when two things are equal? It means that they're the exact same thing. Even though they don't look the same, they are actually the same exact thing. We're going to use that concept right now. In my very first equation, y equals 6x. They represent the same exact thing. They're equal to each other. So we're going to do a little call and response. This is what we would do in class if we were learning this in class. Y equals 6x. What does y equal? And you guys would say 6x. And I would say, what does y equal? And you would say 6x, right? What does y equal? 6x. So wherever I have a y, I could actually use a 6x. They are equal to each other. Well, I see a y down here. And what I'm going to do is I'm going to substitute that in. Remember, it's called substitution. I'm actually going to put in 6x in place of y. Okay, I just did the substitution. If y, I'm going to back up one second. If y is equal to 6x, if they are literally equal to each other, then wherever I use a y, I could actually use a 6x instead because they are equal. They are the same thing. So what I did is I took the 6x and I substituted it into the other equation. Why did I do that? Well, I did that because now I can solve. I can get x's on the same side, and I can solve for x. I had no more y's left. I'll let you get caught up. Divide by 5s, and x equals 3. Okay, so when I substituted in, I had no more y's left at that stage, and I can solve for x. Well, the good news is I solved for x. The bad news is, remember, I'm looking for the point where they cross, so I need an x and a y, right? So all I have right now is my x. I need to go now find the y. Well, if I have x, I could plug it back in. I'm going to use that 3 for x. So then y equals 18. So I solved, sorry, let me get a different color here. Let's see what we got. All right, so the first thing I did is I substituted, okay? And when I substituted, I didn't have any more y's. Then I solved for x. Then the third thing is right here, where I took it and I used it. I actually substituted it back in, which allowed me to solve for y. Okay? Now, a question you may be wondering is, did I have to actually substitute it back in for the top equation? And the answer is no. I could have used this 3 down here, and I could have substituted in for the second equation. Because take a look. If I use that 3 plus 15 would still equal 18 for y. So right here, this is my answer. Bada bing, bada boom. This is a lot to take in. Let's try another one. All right, this is a great one for substitution because I have at least one that has y by itself. I see in the first equation y equals 2x plus 7. What does y equal? Say 2x plus 7. What does y equal? What does y equal? Y equals 2x plus 7. So wherever I have a y, I can actually use 2x plus 7. I'm going to substitute that in. Okay, I just replaced the y with 2x plus 7. Let's go ahead and get x's on the same side. And x equals 1, which is fantastic, right? That's half of my answer. That's my x. But now we need to go plug it back in for y, all right? I mean, we got to plug it back in and find y. So let's plug it back in. And y is going to equal 2 times 1 is 2, plus 7 is 9. So they cross at 1, 9. Just a reminder, you could also put in the 1 here. And in that case, 1 plus 8 is also 9. So either way, you get the 9. Okay? So this is my answer right here. Use substitution. Go ahead and get caught up. All right, so you have a check for understanding. I'd like you to pause this video and fill it out. So when can you use substitution? You can use it when at least one equation has x or y by itself. Substitution only works if y is by itself. False. It can also be x. Number 3, what is the hardest part of substitution for you? This was just a moment for you to reflect on the steps. Is it where you have to substitute 1 over? Is it where you have to solve for one variable and then go back and plug it back in to find the other one? Let's try number 3. I'd like for you to try this first and then check your answer. Use the steps that are provided or take a look at your other examples to give it a try first. So here's what number 3 looks like. I tried to use different colors to help break down the steps. The first step is in red, where you substitute in 2x plus 6 to the other equation, right? Because y equals 2x plus 6. So wherever you see a y, you can put in 2x plus 6. Then you solve that out for x, and you get x equals negative 3. Then after that, you use the negative 3, and you plug it back in for x. When you plug it back in for x, you're able to solve for y, and you get 0. So these two lines cross at -3, 0. Thanks, honey bunnies. Don't forget your gate check.